Hello everybody. Today I want to explain the Kolmogorov-Smirnov test, which is a test which is becoming increasingly used in the econometric analysis, especially because the non-parametric techniques, which is something related to the Kolmogorov-Smirnov test, are becoming increasingly important in the econometric analysis, especially in finance. Well, the object of the Kolmogorov-Smirnov test is to test the hypothesis that a given unknown distribution is equal to another distribution. Basically, the Kolmogorov-Smirnov test tests the equality of two distributions. That is, it tests the null hypothesis, and we call it H0, that capital phi is equal to capital omega, against the alternative hypothesis H1, that the two distribution functions are different. Basically, this is the test. Well, for instance, suppose to have a true cumulative density function, capital omega, which represents the probability that a given random variable, capital x1, is lower or equal to x, given value, while the observed empirical cumulative density function is a sequence capital psi n x, which is equal to this expression, where capital I represents an indicator function which can assume only two possible values. One, if capital Xi is lower or equal to a given value x, or 0 otherwise. So basically, this estimator represents the portion of the population of our sample given by those elements where the indicator function is equal to 1. So imagine to have a sequence of 1, 0, 1, 0, 1, 0, and since n is a number, the proportion of those events for those the indicator function assumes a value equal to 1 represents exactly the ratio, which is the estimator. Well, to go more into details, suppose to have a fixed point x which belongs to the real numbers field, and by the law of large numbers we know that as n increases, the sequence capital psi n x tends to the true cumulative density function capital omega. That is, the limiting probability of the largest difference between the two distributions goes to 0. So the limiting probability, as we say, of the largest, the supremum of the differences in absolute value of the two distributions tends to 0 for any epsilon really small. So there is an important property of the Kolmogorov-Smirnov test, which the Kolmogorov-Smirnov test exploits, which is the independency property, which says that there exists independency of the distribution of the supremum of the difference between the two distribution functions from the true distribution, under the assumption that this distribution is continuous. And to show this theorem, let's define the inverse function capital psi of a given value y as the minimum x such that the cumulative density function capital psi is greater or equal to y. Then the following expression is true. And if I rewrite that expression in the following fashion, we arrive to the conclusion that the probability that the cumulative density function capital psi is lower or equal than a given value eta is equal to eta. That is, it is independent from the true distribution, which is absolutely important. Very remarkable result. Well, now I just provide you a very brief example, which is taken from finance, and the example is about the returns of cocoa and platinum. I performed this example with Stata, and I wrote here the Stata comments. So if you want to replicate this example, you can download the prices of a given asset or a given index. You can calculate the returns, and then you can first of all perform the kernel density estimation. If you want to take a look to my previous video, you can learn something more about the kernel density estimation. And basically what this example shows is that if you divide your time series of data or returns in two subsamples, for instance, here I divided the returns before 1999 from 1990 to 1999. This is the first group, and from 1999 to 2008, this is the second group. I performed the kernel density estimation of return of cocoa. I plot the kernel density function as you will see in the next slide, and finally I performed the Kolmogorov-Smirnov test. This is the syntax, Stata syntax, and the output is the following. So the two-sample Kolmogorov-Smirnov test for equality of distribution functions give this result. The important thing to take a look to is the last row, because the test, if you remember, is that the two distributions are exactly the same. But since, as you can see, the p-value is 0.000, we reject the null. We reject that the two distribution functions are the same. And as you can see in this graph, that means that the two distributions of returns before the 1st of September 1999 and after the 1st of September 1999 are different. Even though one may say that these are similar, the Kolmogorov-Smirnov test rejects this hypothesis. So the Kolmogorov-Smirnov test is a precise tool to evaluate whether the two distributions are the same. Here I performed the same test for platinum, return of platinum. Again I performed the Kolmogorov-Smirnov test for equality of distribution functions, and again my p-value says that the hypothesis of equality must be rejected. And then again I understand that the two distributions of the two groups of observations are different. So that's it for today, and I hope to see you the next time with my next video.